There are several laws when dealing with exponents, and for number one, the first law is any number raised to 0 will always be equal to 1. So for example, we have letter A. For example, we have 5 raised to 0. 5 raised to 0, again, should be equal to 1 because according to law number 1, any number raised to 0 must be equal to 1. Okay? So let's try another example here. How about if you have 6 to the 0 plus 2 to the 0 plus 3x to the 0. Okay? Now let's go ahead and simplify one at a time. 6 to the 0 will give us 1. 2 to the 0 will give us, again, 1. But you have to remember, the exponent 0 is only for x because the exponent of 3 is 1. So that means if x raised to 0 is equal to 1, 3 times 1 is 3. So the final answer will be 1 plus 3. 1 plus 1 plus 3 will be equal to 5. So 5 is the final answer for this one. Okay? Now, how about if you have, let me erase this part. How about if you have letter C? How about if you have parentheses 6x squared y to the third power raised to 0 plus 7. Here you go. Now, if you take a look at it, you have a monomial here, and everything is in parentheses, and the exponent 0 is outside. That means we're going to count everything here as 1, okay, as one term, okay? And everything here is raised to 0. Once again, any number raised to 0 will give us 1. That means everything here inside of the parentheses raised to 0 will be equal to 1 plus 7 will give us 8. And that's the final answer for 8 is the final answer for problem C. Now let's go to law number 2. In law number 2, if we multiply the same variable, if the base of the terms are the same, all we have to do is to add the exponents. Okay? Since we started the x, why not have an example? X squared times x to the third times x to the, squared again, x to the second power. Okay? Once again, we're multiplying the same variable x. So I'll go ahead and copy the same variable, the common variable, and add the exponents, and that would be 2 plus 3 plus 2 is equal to 7. X to the 7th power is the final answer. Okay, now let's try B. How about if you have 5x to the third power times 4x times 2y. Now again, in multiplying, all you have to do is to add the exponents of the common variable. Okay? But before we do that, we have to multiply all the numbers, all the big numbers, we call them numerical coefficients. So we have 5, 4, and 2. So once again, in multiplying, we just have to multiply first the numerical coefficient. So that would be 5 times 4 is 20, times 2 is 40. Here we go. Now, this time concentrate in the variables.
Nathan Gould, please come to the office. Nathan Gould, please come to the office.
So here we got x to the third and x to the third times x. Now remember, there's an invisible 1 in there, so if we add 3 plus 1, it will be equal to 4. And we just multiplied the x and x, which means we still have to multiply the product of x and x to y. Once again, in multiplying, variables, dissimilar variables, all you have to do is to put them together. So that means since you only have one y here, we'll just go ahead and write it beside x to the 4th power. That's it. So that's going to be the final answer for letter B. So to review, when you multiply the same variable, you just have to add the exponents. Number 3. This time, it's going to be the opposite of multiplication, so that means we're going to use the opposite of addition. So when you divide, you subtract the exponents. Let's have A. Let's try x to the 9th power over x to the 3rd power, which means all we have to do is subtract 9 by 3, and that will give you 6, x to the 6th power. Okay? Now for B, how about if you have 12, 15, okay, and you have x to the 5th power and then x to the 2nd power. Now, to get the lowest term of this, think of a number that can divide both 12 and 15, or using your calculator, your TI, what is it? TI-83 plus, just press 12 divided by 15 and then math answer, you'll be getting 4 over 5. And now you can go ahead and apply what we just learned in law number 3, where you just have to subtract the exponents. So that means you subtract 5 by 2, and that gives you 3. 5 minus 2 is 3, and that is the final answer. Now, how about this time if you are having two exponents? One is inside and the other one is another exponent outside. So, okay, for A, here all you have to do is just multiply them. Let's try this. X to the 4th times raised to the 3rd power. Again, multiply them. 4 times 3 is 12. 4 times 3 is 12, and that's the final answer. Now, how about if we have, okay, let's try B. How about if we have 5a squared, b to the 3rd, and then c to the 2nd power. Okay? Now, to simplify this, we have to distribute 2 to every variable and at the same time to the numerical coefficient. So that means 5 to the 2nd, that gives you 5 times 5. A lot of students, a lot of you guys are confused about 5 squared. Some of you are giving me 10. Okay, so 5 squared is actually 5 times 5. The exponent tells you the number of times you multiply the base to itself. That means we have to multiply 5 to itself twice. So 5 times 5 gives you 25. Okay? And then you can go ahead and apply this rule where you just have to multiply the exponents. So 2 times 2, a to the 4th power, 2 times 3, b to the 6th power, and then because there is an invisible exponent of 1, 1 times 2, c to the 2nd power, and that is the final answer for that. Okay? Now, next will be, okay, number 5. Number 5. How about if you have a fraction, say x over y, with an exponent a outside? Well, common sense. These two are inside parentheses, so all you have to do again is to just distribute the exponent outside to a and x and y. So that should give you x to the a power and then y to the a power. Okay? So let's say we have 2 over 3 to the 2nd power. Common sense. 2 to the 2nd, and then 3 to the 2nd, which will give you 4 over 9. 4 over 9 is the final answer. Or another way of solving this is 2 over 3, because the exponent tells you the number of times you will multiply this to itself, then multiply it twice. Now you gotta remember, in multiplying fractions, it's gonna be just multiplying across, straight across. So 2 times 2 is 4, 3 times 3 is 9, which is the same thing as this one. So you guys, it's up to you. If you want to use this or this, it's up to you. Okay, now let's move on to law number 6. How about if you have a negative exponent? X raised to negative n. Okay, according to the law of exponents, if you have a term, if you have a variable, if you have a number that is raised to a negative exponent, all we have to do is to get the reciprocal, but we just have to make that exponent a positive exponent. That's how you simplify variables or numbers with negative exponent. Let's try this. How about if you have 6 raised to negative 2? Okay, so again, get the reciprocal. This is over, the denominator of 6 raised to negative 2 is 1. So just get the reciprocal. That gives you 1 over, and then that negative 2 will become positive 2. Now to simplify this, you're just going to copy 1, and then 6 squared. 6 times 6 will give you 36. Now, I'm seeing a lot of questions, okay, just like this one. Let's say we have x to the 5th, y negative 2, and then z negative 3. Now again, in algebra we do not accept negative exponents, so what we need to do is to make sure that the exponents are positive. Now, since x to the 5th is already, the exponent of x is positive, already positive, so we're just going to leave it there. Now, my problem this time is the y is having a negative exponent, so I have to put it down, making it positive. My z is having negative exponent, so I have to put it up, becomes positive 3. And now that all the exponents are positive, that means we're done with our job here. That's it. X to the 5th, z third over y to the 2nd. This is the final answer.